September 9, 1943. The Mediterranean Sea, off the coast of Sardinia. The Italian battleship Roma, 45,000 tons of steel, the pride of the Regia Marina, steams northward in a desperate run for Allied protection. Her captain, Admiral Carlo Bergamini, has just made the agonizing decision to surrender his fleet rather than see it fall into German hands after Italy's armistice with the Allies. At 15:42 hours, lookouts spot aircraft high above Dornier Do 217 bombers of the German Luftwaffe's KG-100 squadron. The crew isn't particularly alarmed. Bombs dropped from such altitude, nearly 20,000 feet, rarely hit anything. Traditional bombing accuracy from that height was abysmal, typically less than 2%. But these weren't traditional bombs. What happened in the next 4 minutes would mark the end of one era of warfare and the beginning of another. To understand this moment, we must go back 5 years earlier to a drafting table in Berlin and to a man the military establishment had largely dismissed as a dreamer. His name was Max Kramer, a German aeronautical engineer working for the DVL, the German Research Institute for Aviation. Kramer was obsessed with a problem that most military planners didn't particularly care about: accuracy. You see, the prevailing doctrine in 1938 was simple. If you want to hit a target, you drop more bombs. Carpet bombing, saturation bombing. The British would perfect it over Germany. We Americans would demonstrate it over Japan. But Kramer asked a different question. What if one bomb could accomplish what 100 could not? The military brass thought he was wasting his time. Kramer's concept was radical for its time. He envisioned a bomb not just dropped and forgotten, but actively controlled during its fall, guided, steered. Like a pilot flying an aircraft, a bombardier could make real-time corrections, adjusting for wind, for the target's movement, for the inevitable miscalculations of release. The technical challenges were immense. Remember, this was 1938. Computers, as we know them, didn't exist. Radar was in its infancy. The idea of controlling anything in mid-flight seemed like science fiction. But Kramer was undeterred. Working with Telefunken, the German electronics firm, he developed what would become known as the Kehl-Strasberg radio control system. The Kehl transmitter stayed in the aircraft. The Strasberg receiver rode inside the bomb itself. Through this electronic umbilical cord, a human operator could send commands left, right, up, down, all the way to impact. The bomb itself was designated Ruhrstahl SD 1400X. History would know it by a simpler name: Fritz X. Let's examine what made the Fritz X such a remarkable piece of engineering. The weapon weighed 3,450 pounds, heavier than most bombs of its class. But there was a reason for that weight. The Fritz X was designed with a specific mission profile: to penetrate the thick armor plating of capital warships. Its armor-piercing capability came from a hardened steel nose and a dense, concentrated explosive charge of 660 pounds of amytal. But the real innovation was in the guidance system. Mounted in the bomb's tail were 4 cruciform fins, 12 feet across, made of wood and metal. These weren't just stabilizers. They were control surfaces operated by a gyroscope and 12 small spoilers. When the Strasberg receiver picked up commands from the mother aircraft, compressed air actuators moved these spoilers, changing the bomb's trajectory. The Kehl transmitter operated on frequencies between 48 and 50 megahertz. The operator, the bombardier, sat in the aircraft with a specialized control unit, a joystick, not unlike what a pilot might use. But his aircraft also carried a critical piece of equipment: a flare in the tail of the Fritz X itself, bright enough to track even from 18,000 feet up. The procedure was exacting. The bomber had to maintain straight and level flight throughout the bomb's fall, approximately 60 seconds from release to impact. Any evasive maneuver would break the radio connection. The operator had to keep the flare in his crosshairs, make minute corrections, and guide that bomb all the way down. It required extraordinary skill and nerves of steel, which brings us back to the Roma that September afternoon in 1943. The Dornier bombers, flown by some of the Luftwaffe's most experienced crews, positioned themselves carefully. They'd trained for months with this weapon system. They knew its capabilities and its limitations. At 15:42 hours, the first Fritz X was released. The crew of the Roma watched it fall. They'd seen bombs before, but this one was different. It didn't tumble. It didn't drift on the wind. It came straight down, as if drawn by an invisible wire. The first bomb struck the Roma's deck on the starboard side, between turrets 1 and 2. It punched through the armor, 3.5 inches of steel plate, like it was paper. The 660-pound warhead detonated deep inside the ship in the forward engine room. Massive damage. But the Roma was tough. She was built to absorb punishment. At 15:50 hours, 8 minutes later, a second Fritz X was released. This one struck further aft, penetrating the deck and detonating in the No. 2 magazine. The explosion was catastrophic. The forward magazine sympathetically detonated. A massive fireball erupted from the ship's midsection. The Roma's keel snapped. 20 minutes later, the battleship that was supposed to be unsinkable rolled over and went down. Of the 1,849 men aboard, only 596 survived. Admiral Bergamini went down with his ship. It was the first time in military history that a precision-guided weapon had sunk a major capital ship. The Fritz X would claim other victims. The USS Savannah hit off Salerno. HMS Warspite, Britain's famous battleship, crippled. The USS Philadelphia, hospital ship Newfoundland. In total, the Fritz X would sink or damage more than 30 vessels before the Allies developed effective countermeasures. And that's a critical point. Countermeasures. The Fritz X forced an entirely new category of warfare, electronic warfare. The Allies had to develop jamming equipment specifically to disrupt the Kiel-Strasbourg radio link. Ships had to be equipped with ECM, electronic countermeasure, systems. The cat-and-mouse game between guidance and counter-guidance had begun, and it continues to this very day. But there was another lesson, one that would reshape how America and her allies thought about air power. Precision mattered. After the war, American engineers studied captured Fritz X bombs intensively. The reports filed by the U.S. Navy's technical intelligence teams read like revelations. Here was proof, undeniable proof, that a single guided weapon could accomplish what 1,000 conventional bombs could not. In the years that followed, America would develop the Razon and the Azon, radio-controlled bombs used in Korea. Then came the laser-guided Paveway series in Vietnam, the AGM-65 Maverick, the Tomahawk cruise missile, the JDAM, Joint Direct Attack Munition, used to devastating effect in Desert Storm, and every conflict since. Every single one traces its lineage back to Max Kramer's useless design. Today, precision-guided munitions are the backbone of American air power. We've gone from 2% accuracy with dumb bombs to better than 90% accuracy with guided weapons. Wars that once required tens of thousands of sorties can now be prosecuted with hundreds. Civilian casualties, while never eliminated, have been reduced by orders of magnitude compared to the carpet bombing campaigns of World War II. Whether you consider that progress, well, that's a question each generation must answer for itself. Max Kramer survived the war. He was never tried for war crimes. In fact, he continued his career in aeronautics, working on civilian projects in Germany until his retirement. The Fritz X? Most of them were expended by late 1944. The few that remain sit in museums: Imperial War Museum in London, the Smithsonian, the Deutsches Museum in Munich. Inert now, harmless, but they represent something profound. They represent the moment when human ingenuity took a quantum leap forward in lethality, when warfare stopped being about volume and started being about precision. When the factory workers' useless design became the template for every smart weapon that followed. On that September day in 1943, when the Roma slipped beneath the waves with 1,393 souls aboard, the world changed. We entered the age of the guided missile, the smart bomb, the precision strike. Max Kramer's dismissed dream became our present reality, and the world has never looked back.